Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL R9, which has to do with trig ratios and finding the angle measures within these right triangles. So, no surprise, you probably need to remember the special right triangles, at least for the beginning part of this IXL. That's going to be the 30, 60, 90 triangles, along with the 45, 45, 90 degree triangles. And specifically, you have to remember the ratios between the sides. So if you have the hypotenuse of a 30, 60, 90 triangle, you know that the short leg is going to be 1/2 of the hypotenuse, etc., etc. Okay? So we'll go back here and we go to our first problem. And our first problem says that it wants us to find angle T. Okay? Well, let's look and see if that matches up with any of our triangles. Looks like a 45, 45, 90 degree triangle right there. So I'm going to grab that so we can compare. Okay. And so what I'm seeing here is we have a side that might equal 7. So let's pretend this is 7, and then therefore this is 7. And if we plugged 7 into k right here, we're going to look at 7 square roots of 2. Is that what we have here? Yes, 7 square roots of 2, while this side is 7. So therefore, we know this is a 45, 90 degree angle, or triangle, meaning angle T is going to be 45 degrees. Okay, so we'll go over here, type in 45, and that's it. Now keep in mind, this is just the first few levels of IXL. They're going to give you 45, 45, 90, and 30, 60, 90 degree triangles, and they're going to be pretty easy. So let's try this one now. This one looks like maybe another 45, 45, 90 triangle. Okay, and it wants us to find the measure for angle T. So let's pretend this value right here is k, and this one is going to be k times the square root of 2. Okay, well, let's plug in our 14 square roots of 5 for k here, meaning that side is going to be 14 square roots of 5 times 2, which is the same thing as saying 14 square roots of 5 times 2 is 10. Does that match up? No, that does not match up. Okay, so it is not a 45, 45, 90 triangle. So if this is the case, then let's try something else. Let's try the other method by which you are going to figure out what angles are. And that is going to be with our trig function. So remember SOHCAHTOA. That's what we will be using here. So we want to find measure for angle T. So we want to find this one right here. So let's pick out a trig ratio we're going to use to figure out our missing angle based on the information we already know. So we already know the hypotenuse, and we know the leg right here. Okay, so this one looks like a 45, 45, 90 degree triangle, and let's see if that's going to be the case. Okay, so we have both of our isosceles sides here, and here would be k, and then down here would be k times the square root of 2, right? Okay, so let's see if this works. We'll plug k into here. So we're going to have 7 square roots of 10 times the square root of 2. Okay, and that is going to equal 7 square roots of 2 times 10 is 20. Okay, is there anything we can do here? Well, no. Yeah, we're still not going to work very well. Actually, yes. Is there anything we can do here? Well, yes, there is. We can factor the 20, so we can turn this into 7 square roots of 2 times 2 times 5 is 20. So that kind of factor is there. And then because we have two 2's there, we can take a 2 out. So we have 7 times 2 is 14. And then all we have left is a square root of 5. Does that match up with our hypotenuse? Yes, it does. Yes, it does. Meaning this is indeed a 45, 45, 90 triangle. So angle T is going to be 45 degrees. Very good. Okay, this looks like a 30, 60, 90 triangle, so we'll try this one. Okay, again, this is not going to be the entire IXL. The first couple levels are just going to be these special right triangles, so they're kind of easier. Now let's try this one out. Okay, so we know that the hypotenuse is going to be h, the short leg is going to be 1/2 h, and the side here, is the long leg is going to be square root of 3 over 2h. Okay, so now let's plug stuff in. The hypotenuse is 28/7, so that's going to equal 28 square roots of 7. And it wants us to figure out angle F. So this one would be the 30 degrees, and this one would be the 60 if it's true. But let's see if it's true. Okay, so we know this one's supposed to be 14 square root of 21. So let's plug in h and see if that is going to be the case. Okay, so square root of 3 over 2 times 28 square roots of 7. Okay, that's going to simplify to square root of 3 times 14 square roots of 7, because we divided the 2 through the 28. And then when we're multiplying these to combine them, we're just going to multiply these square roots together. So that is going to be 14 square roots of 3 times 7 is 21. And there we have it. Does that match up with what we have over here? Yes, it does. 14 square roots of 21. So this is indeed a 30, 60, 90 triangle, and therefore angle F is going to be 30 degrees. Okay, so that's kind of the shortcut method we've been using. Just because the lower level, again, they're going to be 30, 60, 90, and 45, 45, 90. I'm going to skip ahead to the higher levels where that's not always going to be the case. And this is going to be one of them. Okay, so I will show you what I mean. And because we cannot use those special right triangles, we are going to have to use our trig functions. Okay, and so this one wants us to find angle T. Okay, and so what we are going to do is we're going to use our trig functions to figure out what angle T is, and then therefore be able to use our inverse trig functions to solve for the degree value. And so we want to find the trig function that is going to let us use both of the sides that we know about. So from T, we want the trig function that lets us use the opposite, and then also lets us use the adjacent side. So what trig function lets us use the opposite and adjacent side? Well, tangent, T, equals the opposite over the adjacent, right? So we are going to use tangent. So we'll be using tangent of T equaling opposite is 3, while the adjacent is 6, or just 1/2. Okay, so tangent of T is 1/2. And from here, you can use arctangent to figure out what that degree value is going to be. So you can get your calculator. I'm just going to go to Google and type in arctangent of 1 over 2 parentheses space degrees. Nope. Space radians. Hold on. I'm going to do in degrees. There we go. So converting that into degrees, it's 26.57 degrees. It says round to the nearest tenth, so really it's going to be 26.6. So we have 26.6 degrees. Okay. Let's do a little harder one. Okay, this one works. So we'll grab this triangle. Okay, wants us to find angle I, so this angle right here. So we're going to come up with a trig function that is going to allow us to use both the hypotenuse and the opposite. So what is opposite over hypotenuse? Well, opposite over hypotenuse is sine, right? So it's going to be sine of I, which equals opposite over hypotenuse. And so the opposite is going to be 2.5, while the hypotenuse is 3.1. So now we can use arcsine of 2.5 over 3.1. Okay, arcsine is sine kind of to the -1, or you can do arcsine. You might see it both different ways. For Google, I actually spell it arc, A-R-C, and then sine. So we are going to do arc sine of, and then the numbers were 2.5 divided by 3.1. Okay, we'll do pause or enter. And it's going to be 53.8 degrees. 53.8 degrees. All right, very good. Now let me jump another level and see if there's anything different here in the 90s. And there is nothing different. Okay, they give you radicals here. Not a big deal. You're just going to do h. You're going to find h. And you see you need the opposite and you need the adjacent, which is tangent. So you do arctangent of the square root of 14 over the square root of 59. Okay, and that's it. So I'm going to end the video here. Take care, stay safe, study hard, and I will catch you later for the next IXL tutorial video. Goodbye.